Okay, Assalamualaikum and hello. So let us do some revision for test 2. Okay. So as I mentioned before, test 2 only cover 3.1, the degeneration, and the 3.2 transmission part. So I focus on the first part first, the generation. Okay. So for the generation, of course, you need to focus on the theory. Okay. So what type of generation you need to know? Either it is from mechanical energy or direct conversion, you need to know. Okay, you need to know for each example. Okay, for the mechanical, it's usually what uranium, coal, petroleum. Okay, depend on you. And for the direct conversion, usually for solar energy and fuel cell. Okay, you need to know the theory. Okay, and of course you need to know the how to calculate. Okay, how to calculate the thermal power. So you can see here you have a thermal efficiency and overall efficiency. Okay, so you have something like this. Okay, you have thermal. This is a symbol of efficiency, something like an N. Okay, so thermal. Okay, and then you have electrical, ELEC3A. Okay, and then you have a overall efficiency. So this one is efficiency overall. So overall equals to thermal and electrical. Make sure you know how to calculate this. So this is the energy electrical. Okay, this electrical energy for the mechanical, and this is energy from heat. Okay, so and thermal equals to energy from mechanical divided by, okay, let me check the recording first. Okay, so energy mechanical, energy from the heat, okay, multiplied by 100, okay, to get the percentage. Okay, so this one electrical equals to energy from electrical divided by energy from mechanical, and of course the overall you just multiply this, so you get overall equals to E divided by E hash. So make sure you know the efficiency very well. Okay, and for example, if they give the EE, make sure you know how to convert it to EM. Okay, so I give you example here. So if E equals to 1 megawatt hour, okay, so this is not E maximum, so this is EE. So efficiency of electricity is usually around 90%. So basically EM is just equals to 1 megawatt hour divided by 0.9. You get 1 divided by 0.9 is 1.11 megawatt hour. But usually we don't use megawatt hour, we use kilowatt hour. So 1111 okay, kilowatt hour. So make sure you know how to convert this, and then you need to know how to calculate the kilogram. Okay, if they give one how much, okay, make sure you know 1 kilowatt hour is equals to 860 kcal, and of course you need to know, okay, how to calculate everything. This you have to convert from how many gram of kilogram of coal, okay, kg of coal. You need to know how to convert it to the energy E heat, okay, and then you have to find maybe the efficiency or the output of the electrical energy. Okay, so make sure you know how to calculate this, and of course you have to be careful whether this energy is for 1 hour or 24 hour. Okay, so if the system is 24 kilowatt hour, okay, how about 1 day? How much energy it is? Okay, make sure you know how to calculate this. Okay, so this is the calculation and everything. Make sure you know thermal power station, and of course you need also to know how to calculate the hydro power station. So this one, okay, the weight equals to this one, and energy store, you use this equation. Okay, make sure you need to know how to calculate this. Okay, that's it. So you can practice for hydroelectric and the thermal, and of course the theory. Okay, a little bit of theory. Okay, make sure you know. Okay, for wind, no need to focus too much. Okay, wind, solar. Okay, so focus on the thermal and the hydroelectric. Okay, now for the second part is the transmission. Okay, so for the transmission, okay, you focus, you can recall back, you have where is it? Okay, you have short line, medium line, and long line. Okay, so for test 2, I suggest you focus on the short line. Okay, try to focus on the short line. Okay, and then how to calculate the resistance. Okay, don't forget to multiply by the kilometer. Okay, usually they give the calculation in the kilometer. Make sure you know how to multiply this. Okay, and then you need to calculate, okay, the voltage and the current. Okay, the sending voltage. Okay, so make sure, so usually, okay, this is the common knowledge. Every time they give the voltage, it is a line voltage. Okay, every time they tell you, for example here 10 kilovolt, always assume it is a line voltage. So make sure you know how to convert it to phase voltage. Okay, just divide by 3. Remember, V line is equals to square root of 3 V phase. Okay, so this one is just magnitude, but if you have phase, V line is equals to V phase, okay, square root of 3 angle 30. Okay, something like this. And make sure you know that the phase voltage is the reference, so you have to make sure that it is 0, and then you need to know how to calculate IR. Okay, make sure you know IR is equals to, okay, V line, I line is equals to V line equals to P, okay, P divided by V line. Okay, so P is equals to VLIL cos theta. So from this you can get I line is equals to, square root 3. I forget the square root 3. So if you do this, I line is P divided by square root 3 V line, okay, cos theta. Okay, so this is just a magnitude. Okay, make sure you be careful, and of course the angle you have to add negative. Okay, for lagging you have to add negative, cos inverse power factor. Okay, make sure you know how to do this. Okay, so you have this. Okay, and then you have to find the phase current. Okay, this is the phase current 32. Okay, phase current and the phase voltage Okay, make sure you know how to calculate this. VR plus IR sec. Okay, Z, remember, don't forget to multiply by kilometer. Okay, and then you have to know how to convert the line voltage back. Okay, so from phase voltage go to line voltage, something like that. Okay, and what is another? Okay, medium, no need to worry too much. Okay, medium, no need to worry. And then you have to know how to calculate the efficiency and voltage regulation. Okay, for short line. Okay, make sure you practice. Output power divided by input power. This is the efficiency. Okay, and then the voltage regulation. Okay, don't forget the formula for voltage regulation. Where is it? Okay, so maybe this one. Wait. Okay, find the voltage regulation for short line. I think this one. Okay, there. So from you already calculate the voltage and the current, the voltage and current. Okay, and just make sure you take only the magnitude. Okay, so just insert the value here. Okay, and you get the voltage regulation. Okay, make sure you practice and good luck with your test too. Okay, that's it.